Hi students, good morning. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Don for Peace. In this video session, we shall continue our discussion on your Module 3 homework. This is part 2. So, this part 2 we shall solve questions 4, 5, and 6. Okay? Question 7, you can get the similar problem to question 7 in cryptology part 3, Bacon cipher. Okay, I did question 7, a similar problem to question 7 in that video. Cryptology part 3, Bacon cipher. Okay, but in this in part 2 we shall talk about we shall do questions 4, 5, and 6. Please, it is highly recommended prior to viewing this video that you have viewed the required videos in the video playlist on GCD, Modular Arithmetic, and Algorithms. It is important. That video playlist on GCD, Modular Arithmetic, and Algorithms, it is recommended that you view the videos in that playlist to get a good understanding of the concepts prior to viewing this video. Alright, question 4 says, use the Euclidean algorithm to find the greatest common divisor D of this. They gave us the two, the dividend and the divisor. Okay, so we're gonna find the GCD of that, and find GCD of, and I'm doing an example. So 314,637, and then 152343. Okay, then use this algorithm to find integers s and t. I'm gonna use another one, okay, but they said s and t because if I write s, you might mistake it as 5. So I'll use something else, 2 other letters to write the D, that's the GCD of that, as that. Okay, they gave you the as a linear combination. So we're gonna look for the Bezout's coefficients. That is what they are asking us to find. Then they said solving these types of equations for much larger integers is central to encryption schemes such as RSA, public key encryption. Okay, so they want us to first of all find the GCD of that, and then the second thing is to find the Bezout's coefficient. The Bezout's coefficients. Alright, so we begin. This is bigger than this, so we are good. Okay, so this is 314,637 is 152343 times what? Let's look at, we now do, and with this calculator, you do 314,637 divided by 152343. It gives you 2 point something. Okay, so I will take the integer part times 2 plus, remember this is A equal to BQ plus R. Okay, A equal to BQ plus R. If we GCD of A and B, but we know that A is equal to BQ plus R. Okay, and then the when r is 0, we will keep doing it until the remainder is 0. A is the dividend, B is the divisor, Q is the quotient, R is the remainder. Okay? So when R is 0, then the GCD will now be B. GCD is a divisor. Okay? It's a divisor. So our A is the dividend. Our A is the dividend. B is the divisor. Q is the quotient. And then our R is the remainder. So we already explained these concepts in those videos. Okay? So this will be this times this plus we now do 152,343 times 2 gives us this. Then we subtract it from, it gives us 304,686. Okay? We now subtract it from 314,637. And that is 9951. Okay? 9951. Then we bring this here. Remember, with Euclidean algorithm, we noted in those videos that the GCD of A and B is the same thing as the GCD of B and R. Okay? That was what we noted in that Euclidean algorithm. So now this will now be our dividend, and then this is our now divisor. 9951 times what? So 152,343 is 9951 times. So we do 152,343 divided by 9951, and that gives us 15 point something, 15.30931565. We take the integer part, 15, then plus what? Now we now do 9951 times 15. It gives us 149,265. We subtract that from 152,343, and that is, we have 3078. Okay, 3078. And then we bring this here, this becomes 9951 equal to, and this becomes 3078 times what? So we do 9951 divided by 3078, and that gives us 3.23294347. We take the integer part, okay, plus we now do 3078 times 3. It gives us 9234. We subtract that from 9951, and that gives us 717. Okay, 717. Then this now comes here, 3078 equal to 717 times what? And you must not put these arrows. I am using these arrows to kind of show you, like to show my work, okay? Like to make, I'm using it just for you so that it will serve as a guide, so that you don't, it will serve as a guide, so that you don't put any wrong thing somewhere, okay? So that it will serve as a guide. This is 717. Okay, so we now do 3078 divided by 717, and that gives us 4.292887029. So we multiply this, we take the integer part plus 4 times 4, we put the integer part. Then we now do 717 times 4. It gives us 2868. We subtract it from 3078. It gives us 210. 210. Okay? Then we continue. I'm going to continue here. So the next one will be 717 will be 210 times what? Okay. So we do 717 divided by 210. It gives us 3.414285714. We take the integer part, then plus, we do 210 times 3 is 630. Subtract it from 717. You have 87. 87. Okay? Now we now do 210 is equal to 87 times what? Okay, we do 210 divided by 87 gives us 2.413793103. We take the integer part 2, then plus 87 times 2 is 174. Subtract it from 210, we have 36. Okay? And the next one will be 87 equal to 36 times 87 divided by 36. We take the integer part times 2, okay, plus 36 times 2 is 72. Subtract it from 87, you have 15. So the next one, 36 is 15 times 2, of course. Okay, 15 times 2 is 30 plus 6. Okay, and then 15 is 6 times 2. Okay, 6. At least you know how these arrows go. Okay, you know how the arrows go. So 15 will be 6 times 2, 12 plus 3. Okay, and then 6 will be 3 times 2 plus 0. Okay, 3 times 2 plus 0. So you now look from here, when R is 0, the GCD will be B. Okay, so you look at A equal to BQ plus R, right? So 6 is 3 times 2 plus 0. Okay, when R is 0, so the GCD is 3. Okay, so we just write that the GCD of this is 3. And that becomes our answer. First part. First part, our answer. Okay? Now, the main work now begins. I'm going to erase this here. The main work now begins. It's not too much work though, okay? I don't want to scare you. Bezout's coefficient. Bezout's coefficient. So I'm going to, we don't need this. We are done with this one. So we found the GCD. Please, how do you know that you're right? How do you know? That's the calculator, okay, that I developed for this. www.modular-arithmetic.appspot.com. Okay, www.modular-arithmetic.appspot.com. So you check your work with that. Okay, actually questions 4, 5, 6. Okay, questions 4, 5, 6. you could check your work with that calculator to know whether you got it right before you turn in your work, to know whether you got the answer right. Okay? So we have found our GCD. Now the main work begins. We want to find the Bezout's coefficient. We want to make this a linear combination. Okay, we want to make our GCD to be a linear combination of the dividend and the divisor. Remember, this is the dividend, this is the divisor. So we have to make the GCD to be a linear combination of the dividend and the divisor. We need the two coefficients that will work. Those are Bezout's coefficients. So we are going to start working backwards. We will start working backwards. We might not have space, but as we do, we erase. We erase. And when we finish, we have to check it with the calculator to make sure that it works. You just have to do that to make sure it works. So that is the nice thing about it. You can use this calculator to find your GCD. As for the Bezout's coefficient, when we work backwards, we get it, the linear combination. We check it to see that it works. All right. In any case, we need to see our dividend and our divisor. It is very important for us, okay? Because we need to make this GCD a linear combination of this, of the dividend and the divisor. So in each case, we just have to have the dividend and the divisor. We have to do that. We got to do that, right? We gotta do that. Okay, so we start from here. The GCD, what the GCD is. The GCD is 3 equal to, okay? And this is 15 minus 6 times 2. You see what I just did now? And we are working backwards. We are working backwards to get back to this. But then we want the GCD. You might ask me, why don't you just go ahead and use this? Okay? This is 9951, it's not the GCD. We are going to use this 3 and we will get back something times this plus something times this or minus something. It could be plus, it could be minus. Okay? It's going to be a linear combination of the dividend and the divisor. It has to be that. Okay, we're not going to change this 3. The 3 will be there. It will be there. In the final answer, that 3 must be there. Okay, we are going to keep on each one. Remember, this is the dividend, this is the divisor. Okay, this is the dividend, this is the divisor. Dividend, divisor. Dividend, divisor. Dividend, divisor. Dividend, divisor. Dividend, divisor. So, 15 is the dividend, 6 is the divisor. 36 dividend, 15 divisor. We have to keep, and we need to see that in each case until we get back to this. Then we will see this and this, and we will now find the coefficients. And then we can check our work. Okay, so this 3 is equal to, here, we see that the 6, we have finished with this, we get back to this. The 6 here, the remainder is this minus this. And that 6 is here. So, and the dividend and divisor, 36 and 15, we still need to see it. So we write 15 minus, this 6 here is now 36 minus 15 times 2. Now remember, this is the 6, then times this 2, times 2. Do you see what I just did now? Well, we need to see 36 and 15. We just have to say it. Okay, there will be coefficients with it, but we have to see 36 and 15. We have to say it. So this 6 is this minus this. This 6 right here. Okay? So this will now be 15 minus, we now have to simplify this. We distribute. So this will be 36 times 2. Okay? Minus 36 times 2. Then minus times minus is plus. Plus 15 times 2 times 2. You see what I'm doing? I'm doing it step by step. Because, like I said, the main work just gets started. We just got started. Don't mind me, okay? So just do it step by step so you don't mess anything up. Okay, we only need to see 15 and 36. Now let's get all the 15s together. We just can't leave it like this. Let's get it together. So this will be 15 plus 15 times 2 times 2 minus 36 times 2. Okay, we need to get our 15 together. So this means 15 plus 15 times 4 minus 36 times 2. I'm just breaking it down, showing my work. Breaking it down. So this means 15 times 1 plus 15 times 4 minus 36 times 2. Okay? So this is 15, 1 plus 4, distributive property. Okay, distributive property minus 36 times 2. And this is 15 times 5 minus 36 times 2. So we have 36, we have 15. And if you do 15 times 5 is what? 75. 75 minus 36 times 2 is 72. 75 minus 72 is 3. We don't leave 3 alone, we don't. 3 should be there. Okay, so we've done 36 and 15. Okay, do you see what I've done so far? 15 times 5 minus 36 times 2. See? So we knocked off this, we've knocked off this. Now we will get to this part and we need to see 87 and 36. Okay, we will substitute for whatever 15 is. We always substitute for the remainder. And we need to see 87 and 36. And in each case, it will be good you test it to make sure it is 3. Just like I have tested it now, 75 minus 72 to give me 3. If you keep going and going and going and going and going until you get to the end, and you now find out that it is not equal to 3, you start all over again. You start all over again. Okay, so take this down, or you can pause and copy it. I'm going to now start because I need to say this. So I will start back here. So this is 15 times 5 minus 36 times 2. Okay. The next one, I need to substitute for this 15 because I need to see 87 and 36. I need it. So this will be the 15 here. This is now, let me put a bracket. This is 87 minus 36 times 2. Okay? And then this is times 5 minus 36 times 2. Okay? Step by step. And this will be 87 times 5 minus 36 times 2 times 5 minus 36 times 2. Okay? And this is 87 times 5, okay, minus 36 times 2 times 5 is 10, minus 36 times 2. Okay? I gotta get the 36 together. So this will be 87 times 5 minus 36, and this is 10 plus 2. Okay? You factor by GCF. You factor by GCF. So this is 87 times 5 minus 36 times 12. See that? Now, we've done this step. We've knocked it off. Let us check to make sure it will still give us 3. Let's check. 87 times 5 is 435. 36 times 12 is 432. 435 minus 432 is 3. So it works. We are still on the right track. Okay. Now, let's continue. Here, I will substitute for 36 because I need to see 210 and 87. I need to see 210 and 87. I need to see those. So, I have 87 times 5 minus this 36. Let me put a bracket. Okay? And this, if we substitute, if we isolate 36, we have 210 minus 87 times 2. I close the bracket. Then this is times 12. Times 12. Okay? So this will be 87 times 5 minus 210 times 12. Minus times minus is plus. Plus 87 times 2 times 12. See that? Step by step. Okay? So let's continue. I'm going to leave one more step. So in case if I check it and it doesn't work, then I can retrace it. But it should work. It's gonna work. It's gonna work. Let me speak like American. It's gonna work. It's gonna work. It's gonna work. It's gonna work. Okay, so this is 87 times 5 minus 210 times 12 plus 87 times 2 times 12 is 24. 2 times 12 is 24. Let me get the 87s together. Okay, so this is 87 times 5 plus 87 times 24 minus 210 times 12. So this will give me 87 times 5 plus 24 minus 210 times 12. Okay? So this will give me 87 times 29 minus 210 times 12. Okay, let's check it. Just make sure. 87 times 29 is 2523. 210 times 12 is 2520. It works. Okay? So we've knocked off this. We're getting there, bro. We're getting there. Alright, the next one, I will isolate 87. I will solve for 87. I need to see 717 and 210. I need to see those. I gotta see those. Okay, dividend and divisor. So this will give me, I put a bracket, 717 minus 210 times 3. Okay, I close the bracket because this is for 87. Then this times 29 minus 210 times 12. So this will be, we distribute 717 times 29 minus 210 times 3 times 29 minus 210 times 12. Okay? So this will give me 717 times 29 minus 210 times 3 times 9 is 27. 3 times 2, 6 plus 2, 8. Okay? Minus 210 times 12. I'm doing it step by step. So this will be 717 times 29 minus 210. Okay, factor by GCF. 87 plus 12. So this will give us 717 times 29 minus 210 times 99. Okay, let us see whether it works. So I will do 717 times 29. Because I have 717 and I have 210, I gotta have those, dividend and divisor, in each case. Okay. 717 times 29 is 20793. 210 times 99 is 20790. Works, bro. Works. Okay, so I got this here. I got it. Alright, so I'm going to come here and write this. Write this 717 times 29 minus 210 times 99. Okay. Alright, the next one, I will isolate 210, okay, because I have to see 3078 and 717, I gotta see those, so this will be 717 times 29 minus, I put a bracket, this is 3078 minus 717 times 4, okay, I close the bracket, then times 99, okay, so this will give me, I have to come here because I need space, this will give me 717 times 29, then we distribute, minus 3078 times 99, minus times minus is plus, plus 717 times 4 times 99. So this will give us 717 times 29 minus 3078 times 99 plus 717 times 4 times 99. Let's use calculator to save time. So 396, okay? So let me get my 717s together. So 717 times 29 plus 717 times 396 minus 3078 times 99. Okay? I factor by GCF. This is 717, 29 plus 396 minus 3078 times 99. And that will give us 717 times 29 plus 396 is 425. Okay? Minus 3078 times 99. Alright, I have my 717, I have my 3078. Let's check. So 717 times 425 is 304725. 3078 times 99 is 304722. Works. Good. Works. Thank God it works. Thank God it works. So we knock off this. Alright. Then the next one, I need to isolate 717. I need to solve for 717 because I got to see 9951 and 3078. I gotta see it. Okay. So this will be, I put my bracket here, 9951 minus 3078 times 3, I close the bracket, times 425 minus 3078 times 99. Okay? So let me go ahead and distribute. So this is 9951 times 425, okay, minus 3078 times 3 times 425 minus 3078 times 99. Okay, so let's finish it. I will leave some space here up to here. So let's get the light time. Let's factor by GCF for the 3078. So this is 9951 times 425, okay, minus 3078 times 3 times 425 is 1275. 1275 minus 3078 times 99. Alright, so this will give us 9951 times 425 minus 3078. We factor by GCF. 1275 plus 99. Okay. So this will give us 9951 times 425. Okay. Minus 3078 times 1275 times 1275 plus 99. 1374. Okay. Alright, let's check this. 9951 times 425 is 4229175. The 3078 times 1374 is 4229172. Yay! Yay! Thank God we knocked off this one. Okay? Two more. Alright. Now the next one equal to 2 more and we'll be done with this question 4. Alright. The next one is we need to isolate 3078 because we need to see 9951 and 152343. We've got to see those. Okay, so we need to isolate 3078. So this will be 9951 times 425 minus, I put my bracket here, 152343 minus 9951 times 15, then times 1374. Okay? Okay, so this will be 9951 times 425 minus, we distribute 152343 times 1374 minus plus. Okay, because minus times minus is plus. If we had put minus, I'll be checking the next time it will work. So please, minus times minus is plus. So it's good to always check it after doing each step. So this is plus 9951 times 15 times 1374. Okay? So this will give us 9951 times 425 minus 152343 times 1374 plus 9951 times 15 times 1374 is 20610. Okay? So let's get 9951s together. So this will give us 9951 times 425 plus 9951 times 20610 minus 152343 times 1374. Okay? We factor by GCF. This is 9951 425 plus 20610 minus 152343 times 1374. Okay? So this will give us 9951 times, you do 425 plus 20610. It gives you 21035 minus 152343 times 1374. All right, let's check this. 9951 times 21035. Ooh, it gives us 209319285. Okay, 209319285, and then you do 152343 times 1374. It gives you 209319282. Yes, the difference is still 3. Good. Thank God, the difference is still 3. Okay, we now have one last step. Okay, one last step, and we will get our answer, and we will be done with question 4. And we will be done with question 4. Alright, so this will be 9951 times 21035 minus 152343 times 1374. Okay? Okay, the last step we have to do to get our answer is we isolate 9951. Okay, we solve for 9951 because we need to see the dividend and the divisor. The dividend is 314637 and the divisor is 152343. So this will give us, we put bracket 314637 minus 152343 times 2. Okay, we close this. Okay. Then times 21035. Then minus 152343 times 1374. Alright, we distribute. This will give us 314637 times 21035 minus 152343 times 2 times 21035 minus 152343 times 1374. Comprendez? Comprenez-vous? Comprendez? Comprenez-vous? Okay, so this will give us 314637 times 21035 minus 152343 times 2 times 21035 is 42070 minus 152343 times 1374. Okay? So this will be 314637 times 21035. We factor by GCF minus 152343. Okay? And this will be 42070 plus 1374. So this will be 314637 times 21035 minus 152343 times 42070 plus 1374 will give us 43444. Okay, let's see first whether it will give us 3. Okay? So 314637 times 21035 will give us 6618389295. Then we do 152343 times 43444. And that will give us 6618389292. Yay! Great! Good. Okay, so it's just a little to finish. Now this is minus. We don't want to see minus. Okay? We don't want to see minus. Because we want to get the coefficients. The coefficient could be minus, but the dividend and the divisor will not be negative. No way. Dividend will not have to be negative, and divisor will not be negative. Okay? But Bezout's coefficients could be negative. No problem. So we can write this as 314637 times 21035 plus 152343 times negative 43444. So we see here that this is the dividend. See that? That's the dividend. And this is the divisor. Yeah. And this is our greatest common divisor, GCD, 3. Now, what they are asking us now are the coefficients. The coefficients is what they are asking us. So, the coefficients that they are asking us is this right here and this right here. Okay? So, the two coefficients are, we can now write that the two coefficients are okay, the two coefficients are 21035 and -43444. Those are the two Bezo's coefficients. Okay? But this is the linear combination of those. Alright. Okay, we finished question 4. Now let's get to question 5. Okay, question 5. Let's get to question 5. We are done with question 4. Let us get to question 5. Question 5 says, if f subscript 7 is the mod 7 function. Okay, so if f subscript 7 is the mod 7 function, compute each of the following. Compute the following. A, F25 mod 7, okay, in mod 7 plus F31 in mod 7. B, F of 25 plus 31 mod 7. C, F of 25, F25 mod 7, 25 mod 7 times 31 mod 7, okay, 31 mod 7, and then D, 25 times 31 mod 7. I think that is what they asked us to find for question 5. Okay? That is what they asked us to find for question 5. Okay, folks. We've done videos on modulo. We've done that. And you can check your work with that calculator. Okay? As I said earlier, the calculator, this calculator, you can check your work for questions 4, 5, and 6. After you finish solving it, you can check your work with that calculator to make sure that you actually got it right. Okay? Well, 25 mod 7. 25 mod 7 is what? 25 divided by 7 is 3 point something. 7 times 3 is 21. Okay, so 25 divided by 7 is 3 point something. So take the integer part. 7 times 3 is 21. 25 minus 21 is 4. This is 4. Okay, we did modulo. Okay, it's 4. 31 mod 7. What is the highest multiple of 7? That is another way. Another way you can do it. So 7 times 5 is 35. 7 times 4 is 28. 31 minus 28 is 3. So this is 3 here. Okay? So this will just give you 4 plus 3. And that is 7. That's it. Give you 7, that's it. Okay? Now, 20, in this one, we do 25 plus 31. 25 plus 31 is what? Is 52. 56, I mean, 56. 25 plus 31 is 56. Okay? And 56 is 7 times 8. So actually, this is just 56 mod 7. And that is 0. Okay? Because it's a multiple. 7 times 8 is 56. So that is 0. And this C part will be 4 times 3. 4 times 3. 4 times 3, which is 12. Okay? And then this will give us what? 25 times 31. I would have solved this without calculator, but because of time. 25 times 31 is 775. 775 mod 7 will give us what? 775 mod 7. Okay, 775 divided by 7 is 110.7142857. Then we take the integer part. Take the integer part, which is 110. 110 times 7 is 770. Okay? Subtract it from 775 and you have 5. So this is 5. That's how it's 5. And that's it. That's it for question 5. That's it. That's it, bro. That's it. That's it. You understand what I'm saying? What I'm talking about. Okay? That's it. That's what I'm talking about. That's what I'm talking about. Okay, question 6. Question 6. It says, write the binary, which is base 2, and hexadecimal, which is base 16, expansions for each of the following numbers. They want the binary and the hexadecimal. Okay? Binary and hexadecimal expansions. Yeah. For each of the following numbers. So we have 43. I'm using examples, okay? Because I can't solve the actual question for you. So I'm doing examples and you can now knock it off. So A is 43 and B is 955. Okay. This question also, you can check your work with this calculator. Okay, but you have to show your work. Please do not just write answers, please. You write only answer, you get answer point. Okay, you can, please check your work with this calculator to make sure you got the answer right, but you still have to show your work. You still have to show your work. Okay, let's do binary, okay, for 43. A part for 43. So let's do the binary for 43. So we have a, you know what, let me use here. Let me just use here. Because this might, let me use here. So binary for 43. 2, 43. Okay. So 2 divided 43 will give us a 2 into 42 is 21. 21 times 2 is 42. So this is 21, remainder 1. Okay? Because 21 times 2 times 21 is 42. Then plus 1, 43. Then this is the way you convert it. Okay? this, you want to convert decimal to binary. So you have to divide by 2. Now 2 into 21 is 10. 10 times 2, 20. 10 remainder 1. 2 into 10 is 5, remainder 0. 2 into 5 is 2, remainder 1. 2 into 2 is 1, remainder 0. And then 2 into 1 is 0, remainder 1. And then you count upwards. You now count upwards. You count upwards. So we see that 43 in base 10 will be, we start counting from upwards. 1 0 1 0 1 0 1 0 1 1 in base 2. In base 2. 1 0 1 0 1 1 base 2. And you can even with that, if you don't want to use calculator, just expand this from base 2 to base 10, convert it, and you will still get 40. Yeah, if you convert this to decimal, 1 0 1 0 1 1 in base 2. If you convert it to decimal, you will get 43. Okay? You can also use your calculator to check your work, because calculators have that. Your calculator, your scientific calculator, has DEC, that is the decimal which we use. Okay, base 10. Then it has the BI, at least first it has the BIN, which is the binary. It has the OCT, which is the octal base 8. Binary is base 2. Octal is base 8. Then it has the decimal, which is base 10. Okay, that is the number system we use. And then it has the hexadecimal, which is base 16. Hexadecimal. Okay. You can do it. It is the functions are in your side. It's even here. The functions are even here. In most scientific calculators, you see this. So you can always come back. But I need to see this. You need to show me your work, how you got this. Not just writing the answer for me. You need to show me how you got yours. Okay, let's do 16. Let's do the hexadecimal for 43. Hexadecimal for 43. So we have 16, 43. This wouldn't even take us time for 43 because 43 is pretty much this thing. Hexadecimal for 43. So 16 divide 43. Alright, so you know that in base 16, where should I write this now? Let me write it here. In base 16, in the hexadecimal base, so it's from 0 to 15. Okay? But when you come to 10, 10 is A. 11 is B. 12 is C. 13 is D. 14 is E. 15 is F. So that is why you see that in base 16 you have from 0 to 9, then A to F. Okay? So in base 16 you have from 0 to 9 and then from A to F. That is what you have in base 16. 0 to 9 and A to F. Okay? Because the 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So 16 divided 43. 16 times 2 is 30. 16, excuse me. 16 times 3 is 48. So this is 2 remainder. 16 times 2, 30. Okay. 43 minus 30. 43 minus 30 is 13. And 13 is what? D. Okay? Sorry. Did I say 16 times 2 is 30? I'm sorry. Okay. 16 times 2 is 32. Not 30. My bad. I'm so sorry. Okay. 16 times 2 is 32. 2. Remember? So, excuse me. It's 32. 16 times 2 is 32. Not 30. I'm sorry. So you now do 43 minus 32. And that is 11. So 2 remainder 11. 11 is B. B. Okay? And then you now do 16 divided 2. This will now be 0 remainder 2. Because that will give you 2 over 16. And then you count upwards. You count upwards. So 43 is equal to 2b base 16. And this is your answer here. This becomes your answer. Okay? That's it. Alright, now let's do the next one, 955. For the binary base 2. 955. So 2 divide 955. Alright. 2, I'm going to use calculator to be fast. 955 divided by 2 is 477. Okay, remember 1. Because 477 times 2 is 954. Okay, yeah, remember 1. Then 2 divide 477. This is 238. Remember 1. Okay, 2 divide that will give you 119. Remember 0. Okay, remember 0. Then 2 divide 119. This is 59. Remember 1. 2 divide 59 will give you 29. Remember 1. 2 divide 29 is 14. Remember 1. Okay, because 14 times 2 is 14 times 2 is 14 times 2 is 28. Plus 1 is 29. Okay. 2 divide 14 is 7. Remember 0. Okay, we continue here. We continue here. 2 divide 7 is 3. Remember 1. 2 divide 3 is 1. Remember 1. 2 divide 1 is 0. Remember 1. Alright, folks, we are going to count up. Okay, we'll count up. We're going to count up. This is 7. Remember 0. Here. Okay. So we're going to count up. We don't want to count this twice. Don't count. We will not count this twice. So let me don't count this twice. Okay? Don't count it twice. Alright, so we see that 955 in base 10 will give us 111 0 111 0 1 1. in base 2. And this becomes our answer here. Okay? And if you expand this to decimal, it will give you 955. Okay, last but not the least, let's do hexadecimal. Hexadecimal for 955. 955. Okay, remember that for hexadecimal, remember that we have that 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Okay, remember, that's what we have. Alright, so 955 divided by 16. 955 divided by 16. 59. Remember, 59 times 16 is 944. Okay, subtract that from 955, and that is 11. 59, remember 11. And 11 is B. Okay? Then you still divide this. 59 divided by 16 is 3. So 3 times 16 is 48. So 59 minus 48 is also is 11. Remember, I'm sorry. 59 divided by 16 is 3. Remember, okay? 16 times, you take the integer part. 59 divided by 16 is 3.6875. Take the integer part, so 3. 16 times 3 is 48. 59 minus 48 gives you 11. And 11 is B. Okay? Then 3 divided by 16 is 0, remainder 3. Okay? Because it's 0 remainder 3 over 16. So when you just count upwards, so we see that 955 is 3BB base 16. And this is our answer here. Okay, I hope this makes sense. I hope it is not foreign to you. Okay, if you have any questions, please feel free to ask me. Thank you so much for listening, and you have a great day.